Now, you already know how to determine if the given relation is a function. Now, we will discuss how about if you're given a mapping diagram and a graph. Can you determine if it is a function or not? Consider this diagram a one-to-one correspondence. Is this a function? The answer is yes. A one-to-one correspondence is a function because each element in the domain corresponds to a unique element in the range. How about one-to-many correspondence? Is this a function? The answer is no, because there is a domain which corresponds to more than one range. You have observed that A corresponds to 1, 2, 3, and 5. Then we can say that this is not a function. How about many-to-one correspondence? Is this a function? The answer is yes. This is a function. Why? Because each element in the domain corresponds to a unique element in the range. So you have observed that A corresponds to 1, B corresponds to 1, C corresponds to 1, D corresponds to 1. Then we can say that this diagram is a function. How about many-to-many correspondence? Is this a function? The answer is no, because there is a domain which corresponds to more than one range. So I want you to observe 1. You have observed that 1 corresponds to 2 and it also corresponds to 3. The same with 2 corresponds to 3 and 2 also corresponds to 4. So that is the reason that this diagram is not a function. It is just a mere relation. Now, since you already know how to determine if the given diagram is a function or not, let us now proceed to a graph. So, to determine if the given graph is a function or not, we will use a vertical line test. So, it is a test used to determine if a relation is a function or not. A vertical line drawn through the graph, and if it intersects the graph at exactly one point, then the graph is a function. Now, let us observe this graph. Would this graph be a function? Do you think? Is it a function or not? Now, to determine if this is a function, we will now use a vertical line test. You can use any straight line, like your ball pen or your pencil, or any straight object. So, in this case, I will use a pencil to test if this graph is a function. Now, at this part of the graph, you have observed that the pencil intersects the graph at exactly one point. Okay, now let's try to move the pencil on the other side of the graph, or in the other parts of the graph. So, still, it intersects one point. Still, it intersects one point. So, therefore, we can say that this graph is a function. So, the answer is yes. Now, how about this graph? would this graph be a function? Let us now try to use the vertical line test. You have observed at this part of the graph intersects the pencil twice. Okay, you have observed there are two intersections. So this is the first intersection and the second intersection. So there are two intersections. Okay, if we're going to do this, if we're going to move the pencil, still it intersects the graph at 2 points. Okay, let's move. 2 points pa rin. So, therefore, we can say that this graph is not a function. Which graph represents a function? Is it graph A or graph B? The answer is graph B is a function, while graph A is not a function. Because when we use the vertical line test in graph A, you have observed that the graph intersects the pencil 3 times. While in graph B, you have observed that the graph intersects the pencil once throughout the graph.